Well, hello. Good morning, good afternoon, good evening, wherever you are, whenever you happen to be watching this. For me, it is 4 p.m., 1600, as my clock will say. Saturday, October 23rd, 2021. Why so late? You weren't going to ask? I'll tell you anyway. I had some things to do around the house. And I had my COVID booster shot this afternoon, 2:30 p.m., so about 90 minutes ago. So, hopefully I'll last long enough for this stream. We'll see what goes on here. All right. So what are we doing today? We are going to implement IAssemblyFixture. So for those of you who are not necessarily super familiar with how fixtures work in XUnit, fixtures are for shared context. Today we have two levels of shared context. We have class fixtures and collection fixtures. How does a class fixture work? Class fixture, so you when you write a test, you would add IClassFixture onto the test. Let's see if we can find one of those, right? Let's find IClassFixture. Sure, we're going to find some because we've got some in tests, right? So here's some fixture acceptance tests. This actually looks like a good place for us to start with this stuff. All right, so how does a class fixture work? Well, in this case, what we have is you add IClassFixture to your test class. You point at a class that has fixture information that you want. In this case, it's kind of empty, which isn't super helpful to demonstrate, but let's go take a quick look at the documentation for XUnit.net, and we will go to shared context. All right. And so there's three ways to share context today. We didn't talk about the first, which is not a fixture at all. One is your test class can just use constructor and dispose. And what that means is we will, for non-static test methods, we will new up an instance of your test class before we run it. And so if your test class has 10 tests in it, we're going to new up 10 instances of your class, one for each test. Then we'll run each test and destroy that class. So create, run one test, destroy. Create, run another test, destroy. That's how it works. So constructor dispose is a way to get context into your test. It's not really shared in that sense, but it is a way for you to get data that's created fresh for every test, right? So that's constructor dispose. Let's actually talk about class fixtures, which we're going to talk about. So here's a good example. Let's say I have a database fixture. So what does this database fixture do? It connects up to SQL and then maybe initializes some data in a test database and dispose, cleans up the data in the test database, and exposes that SQL connection inside the fixture, right? And so the test class, when it adds IClassFixture for database fixture, what ends up happening in a class fixture case is we create one instance of that fixture to be shared amongst all the tests. So instead of before where you saw, constructor, run a test, dispose, constructor, run a test, dispose, which all still happens, by the way. There's a step before that and a step after all of it, which is create the class fixture. And you can accept that class fixture as a constructor argument to your test, right? Which is a way for you to get access to that data for the test. So here you see I'm just stashing that fixture away, and then at some point we would write a test. We go grab the DB connection out of here, and then talk to the database. So the advantage of a class fixture is it only gets created once for the entire test class. And so database is a really good example here, why I chose the example for this documentation, because likely what you'd want to do is maybe spin up a fresh database, populate it with some standard data, and then in your tests, what you can do is you could do everything to the database in a transaction that you automatically roll back at the end of the test. And so you have a live database with test data in it, and that test data will be the same for every test, but we don't have to create the database and tear it down for every test, right? We can create it once and then share it. So then what's a collection fixture? Obviously, it is just like a class fixture, except it works for collection. So what's a test collection? Test collection is when two or more classes want to share context, they put themselves in a test collection. And that test collection itself can be decorated with a collection fixture to say, this is data that I want to be shared across multiple test classes. So now if you think about the creation and the deletion, if I had this database fixture on two different classes as a class fixture, what I'd get is two different instances of this database fixture class, one for each test class. However, if I put it in a collection fixture, then what we'll do is we'll make the database connection, populate your test data, because that's what your constructor does, right? And put all the data in the database. And then you can share that database across all the test classes in the test collection, right? And then it'll get torn down at the end of all of that. So that's kind of a way to share that. So what are we doing today? We're doing assembly fixtures. So assembly fixtures is exactly what it sounds like. Gives you an opportunity to run some code before we run any tests across any test classes, across any assembly. We'll create an assembly fixture. You'll be allowed to collect that via the constructor and use it. And then once all the tests in the assembly are done running, we'll tear down that assembly fixture. I just got a call from my friend. Let me text her and let her know that I am live streaming so that she's not wondering how come I didn't answer. Currently live streaming on YouTube. We'll call you later. Okay. Excellent. All right. So that's where we are today. We're going to do assembly fixtures. And it'll be just like collection and class fixtures, except assembly level. So there you go. That is what we're going to do today. Kazu, who is a guy that I worked with at Microsoft Patterns and Practices, he, I think, is still at... I'm trying to remember where he is now. I think he's still working for the same company in Argentina. Clarius? Maybe, I don't know. Maybe he came to Microsoft. I can't remember. Anyway, so Daniel Kozolino, everybody calls him Kazu, obviously, has a version of this that we could go look at for inspiration. I don't think we need that. His implementation is using extensibility points that we won't have to use. And then test ordering, which is kind of interesting. I brought up this other issue as well, which is we support test case ordering as an extensibility point. You can do it for test cases, but not necessarily test cases in a test collection. So test case ordering is something that is kind of also interesting in the context of this, maybe. I don't know. We'll see. All right. So the other thing then is, I don't think there's anything else in here that matters all that much. There's a couple people saying, yeah, I'd really like to do this. I don't really like the workarounds. Yep, I get it. I really don't like the workarounds. Totally get it. All right. So let's get started. So this is this fixture acceptance test is part of XUnit v3 core tests. I think what we want to do is try to express our requirements here. So these are acceptance tests that run test classes here. It'll be interesting to see if we can sort of override in acceptance test v3 the list of assembly fixtures, because I think the way people are normally going to do this is with an attribute where we would say assembly fixture. Like we have assembly trait today, right? So if we were to say assembly fixture and type of, my fixture, it'd be something like that. Like that's going to be the canonical usage. That said, if I did that right now, aside from not compiling, it's going to be difficult for me to make sure that the thing gets created and destroyed appropriately. So I think one thing I'm going to want for an acceptance test is a way to say, by the way, here are your assembly fixtures. So the way this works today is we use a real XUnit test framework object. Like this is the thing that normally runs everything. So we spin up an entire new set of machinery to say, by the way, here's this. And we say, here's our assembly. We go get the discoverer, given that assembly, and then we go find the tests, and then we go get the executor and run the tests that we found. All right. So as an override here, I think what I'd want is we're just direct reflector wrapping this entry assembly. What if I were to take this as test data, test assembly. All right, so you'll take a real assembly or a type, and then do this. So if I were to go to this test assembly, well, we've got a reflector wrap around this assembly. This is going to make a real test assembly. So this real test assembly, at some point, we're going to go ask for, this thing is going to implement. So we have an IAssemblyInfo assembly. So I kind of think what we need is a custom assembly info. Right, because IAssemblyInfo is how we're going to go get custom attributes to go find that that set of assembly fixtures. Right, we'll go get the attributes on the assembly. So what those normally do, like if I go to reflection assembly info, what this normally does in reality is calls, of course, assembly.customAttributes, and then we go ask for the specific assembly qualified attribute that we're looking for, right? So we need a custom version of reflection assembly info where we can override get custom attributes, basically. That could become via test data, but also we just sort of reflector wrap this thing. So we could say reflector wrap. Oh, by the way, we don't have to do this, do we? Oh, that's how we know that we have a real assembly info. So yeah, actually, I'll just leave it there. That's fine. So maybe not in test data. Maybe we'll just do this in reflector wrap. Because reflector wrap is the thing it knows to make a reflection assembly info. And then IAssemblyInfo get custom attributes returns IAttributeInfo instances. Right? So let's say we were to say, yes, give me an assembly, but also give me params IAttributeInfo, probably reflection. Actually, I don't think it matters because it only asks for IAttributeInfo. That's fine. Custom attributes. This list is null. If this list is null, then the behavior is that it returns. So let's not do this as a param. Let's do this as an IEnumerable. All right. So then the behavior is that it returns the custom attributes from the assembly itself. This parameter is designed primarily for use in unit/acceptance tests. Discouraged for production use. Okay. So we need a reflection assembly info that needs to take these custom attributes. We'll do that. Right, we'll grab you, we'll go to the reflection assembly info, and we'll say, hey, you, custom attributes, take that exact same parameter description, throw that in there. Okay, just checking in with my friend. She says, call me when you're done. So I will. Right. So then this implementation for get custom attributes is, well, I guess it takes a read-only collection of IAttributeInfo. So let's go ahead and do that then. That's right. I try to get rid of IEnumerable as much as possible. All right. So custom attributes. So we'll just stash this, right? This custom attributes. No, this custom attributes is custom attributes. And yes, please generate a field. You go up there. And then we come down here and we say if let's do this. We want custom attributes or this. All right. That should be good enough. So basically we'll say, hey, you know, we'll give you back the custom attributes that came in, and if there isn't some, then we'll go get those as well. All right, so nothing I've done here should break any tests, so let's go ahead and run those tests and make sure that I'm not breaking anything. Okay, looks good, didn't break anything. We enjoy not breaking things. So I really like, by the way, I think I should point this out. You may notice that when I run these tests, they're popping up in Terminal. This is Windows Terminal, not the normal CMD, and so the beta version of Windows Terminal right now allows you to specify a default terminal application. So instead of the console host, it's terminal. So if I go back to console host, right, and then we'll close this, and then I run this again, it'll show up in a, well, it should have showed up in a console host, although because Visual Studio is already launched, maybe it doesn't see that setting. It doesn't matter. Anyway. I really like this. This is great. Oh, I love it. Yes, I do. All right, so we didn't break anything. That's good. So from an acceptance test perspective, we have what we need now, right? So let's go to our fixture exception tests. Let's get rid of everybody else. So there's constructors, there's class fixture, there's async class fixture, there's collection fixture, async collection fixture. And then here's all of our helpers. So let's do public class IAssemblyFixture, right? And then let's steal one of these. Test class with extra argument to constructor results in a failed test. That class with extra ctor arg. So that's class fixture, so I don't care about that one. Or do I? Maybe I do. Let's start by stealing all of these tests and then commenting them out, and then we'll bring the ones in that make the most sense. There's a lot of them, isn't there? There's a whole lot of lumps. Okay. Let's, first of all, you're an assembly... No, not assembly. You're an acceptance test v3. Alright, and then let's comment all of you out. Comment all of you out. Alright, so you don't have to be a classed fixture here for empty fixture data. Instead, we are going to do... So we have await run async. Alright, so I think what we do here is say... We probably want params here, right? We need something. And so there's... This is the primary implementation, right? Everybody else basically delegates to that. All right, so let's start with this then. We'll say params enumerable. No, can't do enumerable with params. You have to do arrays still. I want params. Maybe I want a read-only collection. Assembly attributes. We'll just go ahead and set that to null. We know that we can come into the reflector wrap here and then pass the assembly attributes. Which maybe assembly attributes is custom attributes to return for these. I guess that's good. That's a good enough name. So we'll do that. We'll throw you on everybody. All right. And you. And then run for results. And then run for results. Okay. So that means that here I should be able to say assembly attributes. Okay. And we'll say we want essentially we're going to want a reflector.wrap around custom attribute data for an attribute. around custom attribute data for an attribute. Around. See if we have any instances of this. So mocks attributes. That's doing get custom attribute data already. And then reflector tests, wrap, parent attribute, custom attribute data, get custom attributes. So that's how we get custom attribute data from a type. Custom attributes. So there's what kind of targets? Oh. What are our other options with custom attribute data? So all the constructors are not available to us. We have to use one of these. We basically have to use one of these. That's okay. It's a little weird. Like normally you just go get the attributes off of an assembly, but what we'll do is, so that'll be assembly attribute infos. Assembly attributes will be reflector dot wrap. Assembly attribute will be that. So reflector wrap custom attribute data. Get custom attributes. We'll get the custom attributes off of dummy assembly attribute container. Right, so let's do this. And we'll say assembly fixture. Well, so we need assembly fixture attribute as a class before we can do this. But in order for me to do this, it also means that I have to declare a class, declare an attribute class that is usable on a class, even though that's not the way I would normally want to do it. Maybe this isn't the right way to do this. Maybe the right way to do this is, because I don't actually care about reflector wrap. These don't have to be reflection attribute infos. So what about mocks attributes? It's like mocks collection attribute. What are you? So you'll substitute a reflection attribute info with an interface proxy of a blah. We'll just new up an instance of this attribute and implement the things about this that matter. So then what we want here is something like reflection attribute info. We'll do assembly fixture attribute, and then we'll do type fixture type. We'll do this. And this. So now we need the assembly fixture attribute. So Where does collection fixture live? No, that's really not what I wanted. Where does collection fixture live? That's really what I wanted. Okay, where do you live in the source? You live here. So collection fixture and class fixture are interfaces, but assembly fixture has to be a class, an attribute class. You need to be an attribute. Yeah, go ahead, generate a constructor, why not? Attribute, usage, IAssembly, allow multiple, definitely, inherited. There's really no way that matters because we're on an assembly. Okay. Indicates an assembly fixture. Let's see. What's our documentation? Used to decorate blah 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 blah. Okay. Use to decorate xunit.net test assemblies to indicate an assembly which has per assembly fixture data. An instance of fixture data is initialized just before any classes, any tests in the assembly are run. And if it implements disposable, okay, it's interesting that documentation for collection fixture does not, so this got dumped into the remarks, which I really don't like things being dumped into the remarks. I also don't like the fact that this doesn't have documentation links here. All right. So let's fix this. Including IAsync lifetime if it's implemented. After all the tests in the collection have been run, it is cleaned up by calling async disposable, dispose async if it's implemented. Or it falls back to disposable dispose. That's implemented. All right, then we have this. To gain access to the fixture data from inside the test, structure argument should be added to the test class, which exactly matches tFixture. So now I don't need these remarks here. My guess is I really need to fix class fixtures documentation as well. All right, let's grab this. Use to decorate it and indicate test classes and collections to indicate test per class fixture data. An instance of the fixture data is initialized just before the first test class is run. First test in the class is run, including blah if it's implemented. After all tests in the test class have been run. It is cleaned up by calling blah if it's implemented, or it falls back if that's implemented. To gain access to the class fixtures, must have a single parameterless constructor. Class fixtures must have a single parameterless constructor and may take collection fixture types as constructor arguments. That sentence is not is not internally representative. So I still want that logic to be in there. Constructor argument should be added to the test class, which. All right, so before I forget, what that means is I need to fix this up, which is test collection, let's see, collection fixtures may have a public constructor which is either empty or accepts one or more assembly fixture objects as constructor arguments. And then, to gain access to the fixture data from inside the test, a constructor argument should be added to the test class, which exactly matches tFixture. Okay, now we go to assembly fixture. Well, nope, sorry, now we got a class fixture attribute. Let's steal this logic that in collection fixtures may have a public constructor. So that, right? Class fixtures may have a public constructor which is either empty or accepts one or more assembly and or collection fixture objects as constructor arguments. Okay. And then, to gain access to fixture data from inside the test, constructor which exactly matches the tFixture. Okay, so that's my updated documentation for class fixture. And now we take this over to assembly fixture. We got user decorate, actually going to test assemblies to indicate per test collection per assembly fixture data. An instance of the fixture data is initialized just before any tests in the assembly are run. I don't want to say just before, I want to say before. Including async, initialize async is implemented. After all tests in the assembly have been run, it is cleaned up by calling if it's implemented, or it falls back to if that's implemented. Assembly fixtures must have a public parameterless constructor. In access of fixture data from inside, a constructor argument should be added to test class that exactly matches the tFixture. Exactly matches the fixture type. So I could do this as tFixture. Or I could just do this as a type. Obviously, having tFixture on there would allow me to do things like this. right? And then I can go am I not allowed to do that? Generic attributes are currently in preview and unsupported. Okay, well, I guess that answers that question. I can't do that at all. Okay. That's fine. Let's find another one of these. I'm sure we have other instances of this, right? Like assembly trait. Use trait attribute instead. That's fine. So let's go to trait attribute. So you're allowed to have assembly. Not exactly what I wanted. So let's try. Okay. So I just use a standard comment here. The other thing is, obviously, you could do this with strings in the old version. I kind of feel like strings is a thing I love to get rid of. So I think I might, in this case, just not add it. Initializes a new instance of the AssemblyFixture attribute class. The AssemblyFixture class type. Okay. Back to Mock's attributes. So here we have AssemblyFixture. Add a reference to core tests. What, did I put this in core tests? Did I really? No, it's in core. It's in core. Mock's attributes doesn't have a reference to core? I guess this is in common. Reference to core tests. Oh, attribute. It's a name. Right, okay. I'm like, I don't understand what's going on here. Okay, now back to my acceptance tests, which are out here. Okay, so I need an AssemblyFixture attribute for my fixture type. So that's type of empty fixture data. Assembly attribute, come on, be like that. Okay, following constructor parameters did not match, int and string. All right, so I expect this to fail, right? Because it should also tell me class or empty fixture data doesn't match. Or also could not cast an object of type runtime type to system string. What? IAssembly info extensions, test assembly runner. Test assembly runner 137. Target framework. Say who and the what? How's that now? How's that now? Can't convert a runtime type to a string. Oh, Oh, sure. There are other things that are dependent on... Oh, yeah, okay. I understand. So there are other attributes that I'm expected to actually go get. So actually, the way that I wrote this is probably wrong here, as certainly the documentation for this is going to be wrong, because we go do... That's not the problem. The problem is... Problem is this, which takes assembly attributes, which I'm going to change to params here. Oops. Additional, so to return for this assembly, these attributes will be added to the existing assembly level attributes that already exist. Okay. All right, you can be like that. We can go steal this. Oh, you should have a period at the end of your sentence, sir. All right, we'll use that again here. Okay, so instead of this, what we need to do is we need to merge these two. And then we'll also do this, which is guard argument not null. Name of custom attributes, comma custom attributes. So custom attributes. And then we do, does it append? What is it? I can never remember this. Concat. Of course, why didn't I think concat? Nullability of blah blah blah, right. Yeah, that was my bad. And then you're mad because why? Attribute info array does not contain a definition for concat. Custom attributes, whoops. Custom attributes, you're an enumerable of custom attribute data. You're an IAttribute info. Oh, so you're custom attribute data. Oh. So I can't... Right. You're going to reflector wrap all of these for me. So it's more like this. And then this. That makes more sense. Okay. Just so my brain sees this as correct. I have this weird formatting habits now. So, Concat those with these. Better. Okay, now what happens when I try and run my stuffs? Now I shouldn't fail in weird places, although I apparently can't. Yes. You can be... Sure. All right. We'll call you additional assembly attributes. That's what we'll call you. Instead of just assembly attributes. Probably wasn't the best thing anyway. And we're going to call you additional custom attributes. Okay. All right. Still no. Yeah, didn't quite make it all the way down here today. Still. All right. Since this is params, I should be able to do that. Right? How about now? Okay. I want you to fail, but I want you to fail for the right reason. And okay, you built, but why aren't you running? No, because your window is still open. No, we're still failing. Test assembly runner 219. Get target framework, test assembly, get target framework. Assembly, get custom attributes, type of target framework attribute, first or default. Oh, okay, I understand what I did here. Hang time. All right. So this concat is correct, but also wrong. Actually, it's going to be in here. This concat is right but wrong because we do this where clause. This where clause, I'm reluctant to just move it out here. Oops. Right, so we don't know the attribute type there. Actually, it should be up here. So these are going to need to be, custom attributes are going to need to be reflection attribute info. Right, so that way when I have a custom attribute, I can go get the actual attribute instance and see if the types are assignable. Which means reflector, you're going to need to be reflection attribute info. Right, and then acceptance test, you're going to need to be reflection attribute info, reflection attribute info, reflection attribute info, reflection attribute info, reflection. And then one down at the bottom. Which apparently is how I always miss things. Okay, gonna run now. There we go. That's the failure I expected. Like, yeah, you're not legit. Go away. Go away. All right, fine. So, we need something here that's going to start doing all of this. Test class with missing argument to constructor is acceptable. Class with a missing constructor argument. Test class with throwing fixture constructor results in a failed test. Test class with throwing fixture dispose results in a failed test. I'm trying to decide which of these tests are actually legitimate. These are not legitimate. However, I'm going to leave myself a to-do down at the bottom of all of this. Okay. So this test is going to be okay. All right. Let's class the default parameter. Test class an optional parameter. Apparently our passing tests and test class with params parameter. Strange that we don't see anything about cleaning up here. Did I miss the test where we check for cleaning up? So empty fixture data does nothing. Throwing, counted. So counted fixture is used where? Collection with a class fixture, class with a counted fixture, class with a counted fixture. Huh. Oh, so it's a collection and a class. It's interesting. But still, is nobody spying on dispose? I guess we're implicitly spying on dispose by testing things that throw. All right. So I guess this will come back to this. All right. Most of these tests I feel like I'm still not going to need. This I do need. But I need I don't think I want this first. Fixture data is passed to constructor. This feels like the one I care about first. Okay, I thought I did a copy up here, but apparently I did not. Okay, that should fail. Oh, it didn't fail. Why don't you fail? Run async, looking for test passed, fixture spy. Oh, that's because, yeah, you shouldn't, whoops, you shouldn't have had that. Ah, there we go. Collection inspecting, but it was empty. There you go. Okay. So where are we going to run these things? Probably going to be in the XUnit framework executor. So when we say, hey, run these test cases, we get a test assembly runner, given this test assembly and these test cases and the blah, blah, blah. Initialize, so this is where we go when we grab everything. Initialize feels like sets up the collection behavior, parallelization options, and test orders from their assembly attributes. This is probably not the right time to run them. The right time to run them is probably here or here. So that probably gets called from down in here somewhere, right? Test collections. Test collections. Test collections async. Why are there two overrides? Oh, that's test collection, not collections. Let's go look into base class. At some point, all of these should become value tasks. So now is as good a time as any. Alt. So run test collections, orders, and then runs the individual test collections. And run async is the main loop. After test assembly starting async. After test assembly starting async. Set the test context to running. Cleaning up on before. So these look like the reasonable places to hang these things. Oh. So I still in the back of my head, one of the things I'm still thinking about is so this does not have like an IAssemblyFixture. So part of my question is going to be, should I have an IAssemblyFixture? And that way I'm not tied to AssemblyFixture attribute as the only way to get these. Like from an extensibility standpoint, this would make sense too, right? Set public interface. A marker interface used to designate attributes which provide access to assembly fixtures. The default implementation is assembly fixture attribute, though custom test frameworks may wish to provide their own version. So that's really what I'm wondering is that what I want? Because custom test frameworks may wish to provide their own version would imply that the behavior for assembly fixtures lives in test assembly runner and not in XUnit test assembly runner. Yeah. Actually, I think I just talked myself out of this. That's fine. Well, we'll try this out. We'll see what people think. All right. So test assembly runner, fine. XUnit test assembly runner. We need. All right. Before and after are the places where we need to get this stuff. So we can go get a list of the attributes here in initialize. Probably entirely reasonable. Or we can wait until... Actually, we can just wait. Wait until we need them. Test assembly, get custom attributes. All right, so first of all, your value task. Then you initialize. Honestly, I don't know why these weren't calling base. Set synchronization context to the original sync context. That's weird that we're cleaning something up here that we didn't do here. Or did we do it there? Who assigns original sync context? Run test collections async does, huh? Huh. Probably because... Actually, I don't know why. If there's no parallelization, then we just run the test collections as is. Otherwise, we set up a sync context. Okay. It's a little weird, but it is what it is. And you also need a value task. For the moment, you're going to be async, and you're going to be awaited. I don't want to... Do I want to push value task down everywhere? Maybe I do. Maybe I want to push value task down everywhere. Maybe that is what I should do first. That is, in fact, what I'm going to do. I think the only things here are value task changes, right? Yeah. And here, also at the moment, just value task changes. And I just heard you beep. Thank you for the reminder to mute. Okay, so let's add that one. Let's add that one. Let's put a commit in here that says push, let's see, convert, execution pipeline from task to value task. Pick up GPG. All right. Okay. Now, if I come take a look at everything else, let's see if I can steal anything else for that commit as well. All right, this is just reflector changes. That's reflector changes. That's reflector changes. Reflector changes. Those are the tests we're trying to write. Well, the cleanup for class fixture and collection fixture would also be nice. Alright, let's also pick up changes for... Would help. Okay, don't turn left and look over there. They can't see what you're typing. Also pick up changes for IClass fixture and ICollection fixture XML docs. And in fact, I'm going to do that right now. So let's undo. So let's add this. Let's add this. Right. Those are all just doc changes. Make XML docs for IClass fixture and ICollection fixture clear with respect to IAsync lifetime IAsync disposable. Okay, now we'll go add that and that and that. All right, because those are all value task, value task, value task, value task, value task, value task. All right, so that's all value task, although we're going to go fix that. Actually, test assembly runner, whatever. Now, I think the rest of this stuff, none of this is value task. This is all just, yep, this is all just the rest of the stuff. So let's stash that. Oops, I didn't mean to close that. Git A, git commit, now git stash save. Work in progress for IAsync. No, not async. IAssemblyFixture. Okay. Now let's come back here to XUnit test framework executor. All right, XUnit test assembly runner. This is where we were making these changes, right? Right. I don't want an await here. I want this to just be a value task, which means we're going to have to continue down the stack. So test collection runner. All right, let's find task. Yes. You need to be value task. You need to be value task. Well, that's fine. You should be value task. There really isn't a value task when all is there. We can new up a value task from a task, though. Which is fine. You should be a value task. Over here, right, you're a value task. 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 That should get rid of all the reds except for this. All right, next song. Aggregator run async is value task. So we have to as task that and do a task when all and turn it back into a value task. Whatever. All right, create collection fixture async task. As task. I have an as value task there. Did I write that or did somebody else write that? I wrote that. Oh, and it's from object, right. No. Plus I'm in the wrong place. But also no. So you need to be a value task, which means we just await you. Are you the only await? You are in fact the only await. Which means we shouldn't be awaited here. What is your problem? Oh, you're just, yeah. whatever. Okay, you should also be a value task. So that's that. Let's go do the base class. Value task. Value task. Value task. You have multiple awaits inside of you, so that's fine. You stay async. Your value task. You have an await buried in the middle. So you stay async. Perfectly reasonable. Your value task. Okay. Next. Just method runner. Actually, let's do this backwards this time. Let's do this one first. All right. You have an await in the middle, so you stay async. You have awaits in the middle, you stay async. Okay. So run async on a test case. Now also needs to be value task. We're definitely going to hit failure there. Right. I think I wanted you to be whole words. Thank you. Your value task. So you should be XUnit test case runner. Your next. Let's do your base class. Default. Default. Okay, you stay async. You're abstract. Good. Okay. Create the test runner. Makes next unit test runner. Your next. Wait a minute, aggregator run async. Aggregator run async should be able to take function which returns a value task, right? Func task code, func value task code. Oh, I know why. Because we probably have func task of t to return t, but not func value task of t to return t. Entirely reasonable. Turn, await code, catch. Honestly, whoops. All these should be value tasks as long as we're here, right? Okay, exception aggregator. You don't have any other task. You take tasks, but you always return value tasks. Very good. All right. Which makes me wonder how many of those things I actually needed to as task. And that was, you know, shouldn't have killed my get K. What if I do get diff as task? Aggregator run async. So task when all. So there's no task when all that takes value tasks. Is that correct? This is IX unit test case. It's a weird place for this to be, right? Yeah, that's not where I was. Where am I? Scroll back did not help me. So that's an XUnit test class runner. So task when all has to take tasks. There's no value task when all, right? Value task, right. So you need to take tasks. Okay. So let's make sure that all of our when all, or all of our as tasks are actually required. So those are going to be tasks. Need to be tasks for when all. So need to be tasks for when all. Okay, that's it. I didn't think I did too many. Okay. Very good. Back to test runner. Test runner's all okay. How about XUnit test runner? You need to be a value task. You have an async in the middle, so you stay async. You need to be a value task. And we go to XUnit test invoker. Let's go to the base class. Let's go for task. Value task defaults. Value task defaults. Task from result. This method's been removed in favor of get value task from result. Yep, that makes sense. I think I can probably get rid of this. I don't know. I mean, it has no references. Given an object, will try to convert. Object is null, return null. If object is task. If you're created but you didn't start, then you get thrown. Otherwise, you get a value task wrapped around you. If you're a value task, you get returned directly. You could be just like that, as long as we're here. And then if it looks like you're an F# async of t, then we get a start as task, gives us the task back, and then we do yep. Use pattern matching. Okay. You need to be value task. Aggregator run async. So we have one where we take func of task of t, and we have one where we take func of value task of t. Everybody returns a value task. I see. All right, from a reference perspective, we have one reference to this func of task. Literally what we're trying to get rid of. Got one reference to this one. Just again, test invoker. Guess we'll find out how bad this is. And just convert ourselves over to value task wholeheartedly, right? Wait a minute, what is this doc? Async task, async value task, and async void, as well as creation, disposal, and test class. Async functions in F#. It's true, it does all that. I suppose VB is also true, but whatever. Okay. So now get task from result, right? This is dead. It's fine. Get value task from result. I think that means we can just delete this. Given an object, we'll attempt to convert instances of task or F# async of t into value task as appropriate. We'll return null if the object is not a task of any kind. Not a task of any kind. Let me split it. There you go. Okay. Keep searching. Okay. Over to XUnit test invoker. You're a value task. You're a value task. You're a value task. So I can give you a empty value task, one wrapped around a task, one around an iValue task source with a token. Okay, so none of those. Okay. I think that plumbs it all the way down. You need to be a value task. 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 Summary is a run summary. So apparently we can new up value task from a result as well. For value task of t. It is kind of weird. I feel like there's no way to manufacture a faulted task. Doesn't that feel weird? Like the fact that I had to make a task completion source, set that to faulted, and then wrap this up feels weird to me. Well, happens. Who else? And then you. And we're gonna do what with this task? I'm going to put you in a list either way, right? All right, as task. Because what we're going to do with this is Parallel and non-parallel get used here. So those just get awaited. Those just get awaited. I think I can just value task these. And then I don't have to as task this. Task runner. Okay, the sync context, we do task factory start new with that sync context. True. What does we do task run? So a function which takes a function of task of run summary and returns a task of run summary. There's no value task factory or anything like that. So if I were to return, say you need to return a value task. Oops. Then I'll wrap you around. And then you should take a value task. Except you can't because task run doesn't allow you to do that. Task runner takes a func of task. Wait, what was this? Was this just task? Is that what this was? Just task? It's just task. That's why. Okay, what's left? Actually, you know what I should do? I should leave this like this. And I will take a value task here. Then task factory start new, which wants task of value task does not return, not contain definition of unwrap. Can't convert from a task of a value task of a blah to a blah. Right? We'll do the as tasks up here. Okay. Bunch of things downstream that need to be value taskified now. Okay. Anything else? Okay. You, default, you, new, you, default, you, default, you, okay. You. Okay. Closer. I like them apples. Those are some very tasty apples there. I mean, that's what I appreciate about you. Simplers. What are you upset about all the way up here? Time to implicitly convert a value task of run summary to a value task. Wasn't that interesting? So it throws async. Can accept a value task, but not a value task of t. Value task is your return type. Where's value task of t? It's your return type. And value task of it. No. All right, I can see how this is going to be a problem. We'll come back to you in a minute. Could be value task of object. All right. Do we need... Oh, I already did that part, right? Do we need assert throws async for value task of object? I feel like hopefully that would be enough. Because this thing returns a run summary, and a run summary would be... Actually, everything should be compatible with object. And since we intend you to write lambdas here, that seems like it'd be all right. So that's this. And this. And here's probably all the assert throws. Okay. Well, we will make the change here. Hope for the best. Okay. Does that make all of you guys happy? Makes some of you guys happy. Can I convert a value task of run summary into a value task of object? Can I convert a lambda expression to the intended delegate type because some of the return types in the block are not implicitly convertible to the delegate return type? The delegates returns types. Wow. This really sucks. I was hoping object would cut it. Apparently that's not going to do it. We can't just do that. So I guess that means these changes aren't really helpful. Yep, these changes aren't really helpful. Which I guess is good because it means I don't need to go make changes anywhere else. But what it means really is this. Assert.isType ex. You need to be awaited. You're also going to be an invalid operation, right? Also going to be an invalid operation, right? U2. 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 Who else? Come one, come all. Okay, let's take a look at what we did. before you get too excited about that, let's do an undo, then an add. Now you can go run your tests. Okay. So value task, value task, value task, default, value task. Sure, sure, sure. Looks good. Looks good. Looks good. Looks good. Looks good. And good. And good. And goodbye. Run async for func of task. Instead, we have func of value task of t. And then all those look okay. All those look okay. Those look okay. Okay, we're all looking all right. Get close to the end here too. Looks good, looks good, looks good, looks good, looks good. Okay. Changes look reasonable. And all of our tests passed. There we go. Let's pop our stash. All right. Now here we are with all of this, and I'm pretty sure something in here broke someone somewhere. That's why we went down this path. Things returning value tasks. Okay, so now we're back to trying to find a place for AssemblyFixture to get injected, which we believe is XUnit. What was this? Assembly runner? Was it assembly runner? Yeah, so after test assembly and before test assembly. So this is where we want to set this up. So when we're about to start, all right, we're going to need to keep a list of these things that we've ran, but assembly fixture attributes is assembly. The test assembly? Yeah, test assembly, assembly, get custom attributes for type. type of assembly fixture attribute. We're going to need to keep the assembly fixtures that were run. List of now that's interesting, isn't it? Assembly fixtures. So here we're going to want to do right. You can just be in line, that's fine. Here, and I attribute info. Given that, this is runtime, so I need you to be like a I need you to be this. But I probably can't quite do that. I do have a diagnostic message sync, right? So if assembly fixture attribute is reflection attribute info reflection assembly fixture attribute. Otherwise, reports failure. Come back to that in a minute. So we go get the attribute. And is this so you should be info. God bless America. You actually, I might not care about that. I just want the argument, right? Right, I actually don't care about that. If ctor args count is 1 and ctor args 0 is type fixture type. Else report the ctor argument failure. I already checked count. Might as well just do first. Nobody cares about the single because we're already there. I really wouldn't want you to throw anyway. So if you're a fixture type, then I should be able to create instance. Where do you hang off of create instance? Where'd my brain go? Create instance. Activator. Okay. Fixture type. We're going to try this. All right, because you could throw all kinds of things. Report creation failure here. It's fine. So assembly fixtures, add fixture, which data create instance gives me back a nullable object, which, okay, assembly fixtures, you want to hold nullable objects? I'm fine with that. Don't need the temporary. Okay. I'm going to throw this out here. Just in case any of those things throws. And here, to do cleanup. So how do I get this stuff threaded through? The answer is it's going to have to go into run test collections. Where do fixtures get threaded through today? So like if I go to XUnit test collection runner, all right, where do collection fixtures? So there's collection fixture mappings. Get fixture mappings that were created during blah. Dictionary of type and object. Interesting. Values of type disposable. So there's our cleanup. Why do we have this as a dictionary? Create collection fixture. So we do an aggregator run to constructor invoke everybody. Oh, that's interesting. We constructor invoke because we could theoretically take a diagnostic message sync. All right, so that's something that we probably also need to do, isn't it? All right. That's reasonable. All right, I need a moment, so I will be right back. Yeah, I'm right back. All right, I'm back. Looking at all of this, now remembering why this stuff is all in a dictionary. And the reason it's in a dictionary is because you could specify the same type multiple times, but you only want a single instance of it. I suppose that is true for assembly as well. So this whole create collection fixture, like I want to steal this for create assembly fixture, obviously. Creates an instance of the assembly fixture type to be used by the test. Assembly. If the fixture can be created, it should be placed in the collection fixture mapping. In the assembly fixture mappings dictionary, if it cannot, then the method should record the error by calling aggregator add. Type of fixture to be created. Excellent. So there's parameter infos. And then we need assembly fixture mappings. Assembly fixture type, blah, had one or more unresolved constructor arguments, blah, okay. So, alright, so if I go to collection fixture mappings, let's go steal that. As assembly fixture mappings. All right, and then we'll grab this up here, and you'll be assembly fixture mappings. So there's that. So there's create. So what do we do in after blah 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 here? Create collection fixtures async. My guess is okay. Create collection fixture, create collection fixtures async. All right, create assembly fixtures. So we don't need you. I don't need you. I think I deleted code that I wanted to keep. But maybe not, because it's create. All right, get interfaces. I don't care about get interfaces. What I care about is for each var attribute info in test assembly.assembly. Get custom attributes, type of assembly fixture attributes. All right. attribute info dot get constructor arguments single as type. So let's not do that. Let's do this. No. Null, literal, or possible null value. Right, because of course. If fixture type not equal to null, create assembly fixture for the fixture type. Then we say assembly fixture mappings. Go get all the value async lifetimes. Do the initialize asyncs. And then wait for everybody to return. So then the cleanup, since we're stealing everything, where's the after? Where's the before? Sorry. So here's our cleanup. We do that, then we do that. We run all the disposes. So the collection fixture mappings must get passed somewhere. So they get passed into the test case runner. So the test assembly runner, which news up a test collection runner, is obviously going to do the same thing, right? So dictionary of typed object assembly fixture mappings. Right. The assembly level fixtures. Assembly level fixtures. That's good enough. Collection fixture mappings. All right, you get passed down into run test class async. You're just going to take an iDictionary of collection fixture mappings. So apparently we want to take iDictionary. That's fine. So in theory, what we should be able to do is we should be able to coalesce these dictionaries, right? Let's go take a look at what test class runner does with this. Because you have class fixture mappings here. We have collection fixture mappings there. I really don't know why you're set aside. You don't need to be set aside. That said, you can absolutely be read-only. Okay, so test class runner takes the collection fixture mappings. And the class fixture mappings, it generates itself. Initialized async fixtures. What are you? Hash set of async lifetime. Did you have one of those in collection as well? You did not. Okay. Where do you get used? Your task went on with all the uninitialized fixtures, run them, sure. So the cleanup is just class fixtures. Really not clear. Is this to prevent the double creation? Hmm. I really don't understand. What is the point of this? It's got to be to prevent duplication, but why doesn't this have the same problem? All right, this is always going to run right over the top. Oh. Okay, so class fixture mappings are used in cleanup. for each class fixture of T on the... It's got to be because of this combination of things that come from test class and the test collection. It's got to be why there's a duplication. You don't really have that problem elsewhere. Okay. I understand now. So then class fixture mappings should be used by the thing that creates a test class instance. So it doesn't go here because that already exists, right? So select the test class constructor. Try to get a constructor argument, which is going to pull from class fixture mappings or collection fixture mappings. Which means you also need to pull from assembly fixture mappings. All right. So we need assembly fixture mappings and class fixture mappings. All right, and then that's where we get mapped in here. So the collection runner now, we should have a failure here because we need to pass assembly fixture mappings, right? Anybody else? And where was our test? Our test was in fixture acceptance tests. Let's pin you so you don't disappear anymore. Well, let's see what happens. Well, the build fails for starters. Okay. Don't think it's going to matter here. Well, I'll just pass in an empty dictionary. Oh. So looking at how this is done, no, I don't think I want to do this. No, I think I actually want this. So over here, we definitely will take in collection fixtures. which I guess means, in theory, we should take in assembly fixtures here. Okay. Okay. Test passes now. This class fixture, we don't care about that. This collection fixture, we don't care about that. So this passes now. What about you? Do you pass now? You should pass now. You do. Good job. Test of the missing argument is acceptable. Alright, so there's an empty fixture attribute. Let's do an object fixture attribute is mocks assembly fixture attribute for type of object. Class with missing CTOR args. That should be okay. Yeah, I didn't think I was going to get lucky enough to be able to do that. Can't name a params, huh? It's worth a shot. That should just work. Test class of the default parameter. Sure, why not? Here with that. Here that. Oh, right. Okay. Test class an optional parameter. Not you. You're an assembly fixture. Oh, you know what? We can change these to the new run for results async. Which I think is going to be test passed with display name. Sure all of those pass. They do. One last here. This class with params parameter. Take you. Take you. Oh. Oh yeah, I gotta pass the assembly attribute in there. And also this needs to be assembly fixture. Report on failed fixture creation and cleanup. Well, oh, that closed more than I wanted. Okay. Let's see what happens here if I do this. So we have a throwing CTOR, we have a throwing dispose. Throwing CTOR fixture. Don't think... I am kind of curious to see what happens here. Because I honestly don't know what's going to happen. This is like literally the worst feature in Visual Studio. You think I'm throwing exceptions that I'm not catching, but I'm catching them elsewhere via reflection. You're close to being smart, but just not smart enough. It's not smart enough, bud. Alright, what messages did I get? Got a test assembly starting and a test assembly finished. Would these have come through as diagnostic messages? Is that why? We don't collect diagnostic messages, do we? You return back message sync messages. So you don't care about discovery, but you do care about the run sync. Actually, let's see. Let's call this the run diagnostic message. Actually, I can't do that, right? The only diagnostic message sync comes in here, isn't it? Yeah. Can't do it that way, can I? I do have to do it up here. What are you upset about? Oh, you're upset because we're running. Create. Return a result. Oh, the return result. So I want you to put in the run sync messages list for your message. What's your problem now? Try again. Run. So slow in the debugger. 10x slower? 50x slower? I don't know. It's a lot slower, though. Too slow. Still only 2 messages. So aggregator. I'll be honest, I expected more. Okay. Did I break anything else by plumbing those diagnostic messages through? It's quite possible I did. Let's go skip this. We can just run test core console, I think. Doubt there's going to be any difference in .NET Framework versus .NET Core. So there's a test assembly cleanup failure. Oh, a little extra space hanging out there, buddy. Where do you get newed up? Wow. That's severely wrong. Sure, I have many of those copy pasta nonsenses. Okay, let's ignore tests. Looks like a test assembly runner. Don't care about reporters. Don't care about the delegates. Yeah, I don't care about the reporters. I don't care about the syncs. I care about the tests. I do care about this. I do care about this. Assembly run. No, I don't care about that. Section 2 message adapter. We'll come back to you in a minute. Test assembly runner. The aggregator has exceptions, then we report them back. That's not a diagnostic message either. That's a cleanup failure. But what about throwing up front? Shouldn't be docked, I don't think. All right. So create, it's going to be in create. Aggregator run AssemblyFixture maxing constructor evoke constructor args. So this aggregator, create AssemblyFixture. Create assembly fixtures. Create assembly fixture. So create assembly fixtures async. Happens here. So the aggregator right. So the test assembly runner awaits this and then doesn't ever look at the aggregator again. And it clears the aggregator here. So we don't have, for example, a test assembly Yeah, isn't that weird? What am I going to do with all those things? At the moment, it would get pushed down. So here's my thought. Let's take this code away for a second. We're going to pin you too. My guess is it gets pushed down into the test collection, the first test collection it runs. Yeah, class with throwing fixture constructor. Like throwing CTOR fixture, fact, test. What now? Nothing else failed over here, right? Right. How about now? Collection starting, class starting, method starting, case starting failed. Three exceptions. Attempted to divide by 0, and the following constructor parameters did not have throw. Yeah, so our attempted to divide by 0 is still sitting out here in the aggregator. Who else uses this? Class of the throwing fixture constructor. Did I delete this? Is that what I did? It's interesting that it got all the way down there. For a class fixture, that kind of makes sense. Does it fail every single test? It's kind of weird, right? It's kind of weird. But it probably does fail every single test in the test class. As we wait and wait and wait. It's in messages. What the hell's wrong with you? Show me what's in messages. You're busy. What are you busy with? Unsafe to evaluate. Full of horse poop. All right, so your exception messages is attempt to divide by 0. In throwing CTOR fixture. So they don't take it as a right. So I guess that would make it mean that every test fails. All right. Throwing constructor fixture. Here we go. Some sheesh. Apparently can't type anymore. Move to namespace. What's your problem, Jimmy? Throwing CTOR fixture. I'm going to need to move you out. Just a moment. Just so you're in scope. All right, run everybody. Do they all fail with divide by 0? That's really what it comes down to. All fail with divide by 0. Except for the 2 that got skipped. Everybody fails. I'm not a huge fan of that. But it's what we've already been doing. The question is that what we should continue to do? I guess maybe. What are my alternatives? So my alternatives would be, well, let's say we can continue to have what we have now. It's one alternative. Second alternative would be you can only fail the tests that depend on the fixture. But then if the fixture is just kind of like ambiently setting things up and failing, then I don't know. Third alternative would be come up with the idea of another kind of failure. So you'll notice that we have a cleanup failure for all the things that could fail cleaning up. But we don't have a startup failure for anything. Problem with startup failure is with systems like VS Test. It would ask us to run tests, and the only way you can actually report failures is by associating them with tests. So it's kind of like, I want you to run the aggregator, but I also want to just try catch around you and throw you in an exception that makes it clear that this was a failure during construction. Right? Alright, so the message I would be looking for would be a test failure message. That is a very specific exception that wraps the other exception. Normally I hate exceptions that exist just to wrap other exceptions, but like just that naked thing sitting out there isn't super helpful. Let's do this again. All right. No, you want to be above, don't you? Yeah. So it's kind of like what I want is so here's constructor invoke. This is done inside aggregator run. And then so that's invoke. It's kind of like what I want is this. Call this a fixture exception. How about that? Fixture startup exception? You're an assembly fixture. This is your fixture type. And that's the exception that you have given us. Fixture startup exception. You're undoubtedly going in the SDK. Probably in v3. Probably in runners. These are literally all runners. Runner. So many runners. Not the framework. So that's all of those. Those are the abstractions. Those are all the test cases. Those are the utilities. Test class exception is an exception. Represents an exception that happened during the processing of a test class. Typically means there are problems identifying the correct test class constructor or problems creating the fixture data for the test class. Really? Okay. Excuse me. Format constructor args missing message. Okay, how many else? How many else's? Collection fixture type blah. Class fixture type blah. Oh. So we already have this test class exception. Only takes a message. Only takes a message. Excuse me, test assembly runner. Collection fixture type full name may only define a single public constructor. Oh, this is this should be assembly fixture type. Assembly fixture type. Oh, isn't that interesting? So if I were to do test class exception here as well, I would need a message, which would be something like assembly fixture type dot full name through during construction. Right, and then I need the inner exception. So I need another one of these. Test class exception, string message, exception, inner exception, base message, inner exception, right? Interesting that I have this class sitting around and basically never used it. All right, let's see what happens here. Assembly fixture type throwing season through during construction. Exception has been thrown by the target of an invocation. Attempt. Oh, target invocation exception. We should unwrap that. That's kind of ridiculous, right? Unwrap. Attempted to divide by 0, blah, 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 blah. So now every test fails with a more reasonable message. So now it's not the only place that it could throw, though. So the other interesting thing to me is that I don't have tests around like this. Throwing initialize async fixture. So my guess is that what that means is that gets reported in a crappy way. Yep. So we should fix that too. Assembly runner. Yeah, that's here. Wait. Try. Throw new test class exception. And we want another message just like the other one we had. Just like this. AssemblyFixture type through during initialize async. What the fixture type is, this is a fixture.getType full name, right? Oh. I don't know why I removed that as task. There you go. AssemblyFixture blah through during initialize. Through during initialize. Through during. During is a weird word there. Through in initialize async. Through in its constructor. Yeah. Oh, maybe like this. That feels weird too. Okay. All right, given all of that, all the tests run again, right? Okay. And then we'll do a dispose async here as well. Right. Hey, you can even be one-lined. Why not, right? All right, so throwing CTOR, class with throwing CTOR. So these tests I thought I didn't need, but I definitely need. Test class of missing argument to constructor is acceptable. All right, so you need to be here. I guess I want both of those. All right, so we need, instead of that, we need this. Mux assembly fixture attribute for this. What have I been calling this? Assembly attribute. Okay. That is not correct. This is going to be test class exception. A new step. It's an aggregate exception. Why are you an aggregate exception? Oh yeah, you shouldn't have class fixture on you anymore. That's why. Through in its construction. I should say constructor. Let's do this as a collection. You can be constructor, sir. Okay. You can be class with no argument. Class with no CTOR. And you can just reuse class with no CTOR. Just a simple test class. How about that? How about just test class? You're going to be throwing initialize async fixture. No, this is dispose, right? throwing dispose. We're going to do this. Blah, 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 blah. Through in initialize async. No, through in dispose is what that should say. Let's do all 4 of these. Test class with throwing fixture initialize async. Throwing initialize async. And dispose async. Dispose async. So you're that. You're that. And you should be that. Okay. Actually, you guys are test fails. You guys are test class cleanup failures. Actually, shoot. They're not going to be test class cleanup failures. You're going to be test assembly cleanup failures, right? Is this still a test class exception? Maybe there should be like a test fixture exception. Test class exception. During the processing of a test class, this typically means there are problems identifying or problems creating the fixture data. Right, so we should have a separate one of these for test fixture exception. That happened during cleanup of a test fixture. Which makes me want to call a test fixture cleanup exception. Which means really only this one. Okay, file got renamed. Good. So then that means over here what we should see is test fixture cleanup exception and test class test fixture cleanup exception. Through and dispose, through and dispose. Okay. So 2 of those are going to pass, 2 of those are going to fail, because we obviously haven't wrapped dispose or dispose async yet. Okay, let's go do that. So let's just copy this catch. So before finished is going to do dispose. So this select. And then this. That. that interesting. Except, I think I did this wrong. In fact, I know I did this wrong. Let's try this again. This is the bit. Right, then I need to put the try catch around. This is going to be test fixture cleanup exception assembly blah 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 fixture get type full name through in expose async. Okay, that should fix one of those tests. And then the other one does this. Right. Through and dispose. Excellent. Okay. Default parameter. Okay, this is the stuff I don't need anymore, because we have determined that that is all working as expected. We clearly need to do async assembly fixture. This is literally things I was going to go. Yeah. Come back to you. So async class fixture. Fixture data should have been set up. Why? Two class fixtures and tested, each one is only initialized once. Regression testing for whatever. Throw if not completed of alpha, throw if not completed of beta. Setup calls. What is this? Initialize more than one. If the test class includes more than one async lifetime, all existing class fixtures will have their initialize async calls re-invoked, and on test cleanup, the number of calls to initialize async will match the number of calls to dispose async. Class includes three class fixtures, alpha, beta, gamma. Alpha will be invoked 3 times, beta twice, and gamma once. Collection fixtures are also affected. Create a composite text fixture? We made a task one all to be concurrent. Sure. Stop repeated initialization of async fixtures. Okay. So that's the uninitialized, the initialized async fixtures thing. I'm not 100% sure exactly how. This bug materialized and why only in classes and not in... All right. Well, that answers the question I had like an hour ago. Well, there's 0 authors and 0 changes. Well, because you'll only look for 12 months. Okay. So weird. All right. I'm going to go look at XUnit test collection runner. All right, we'll put a test assembly runner over here. All right, this is dispose async, so that's this. And this is aggregated run. And then this is this for aggregator run. And then lastly, this is initialize async, select. So those are the 4 changes I made. See how many tests I broke. 5. Not 4, 5. Fine. Looks like in collection fixture 2 and in async collection fixture 3. So let's hit this one. Test collection cleanup failure. And then I feel like we should steal some of this stuff. Right. So that is initialize async. So let's go look for test class with throwing collection fixture. Test class with throwing collection fixture. Setup async. It's very incorrectly named. Okay. You should be a collection fixture. Dot. Throwing setup async. Identifier. Async, okay. All right, so that should get me down to 4 failures, right? Okay. Test class of throwing collection fixture dispose async results in failed test. Collection fixture. Throwing dispose async, identifier. Throwing dispose async fixture. Right. Dispose async. Let's bring the kind of want to split it. So this is what dispose async look like, right? Should be a collection fixture, throwing dispose async fixture, with throwing dispose async, class with throwing fixture dispose async. Okay, down to 3 failures now, right? Still 4. Test class with throwing collection fixture dispose async results in failing test, right? Search single, run, test collection cleanup failure, right? Should be only one of those. Should be that. Oh, no, you shouldn't have iCollection fixture. Oh, no, you should. Never mind. It's fine. Throwing helps if you have the right name. Try and fix wrong. That happens. So the last one here in async collection fixture is this one. Throwing collection fixture dispose async results in failed test. Disposable. Explain. How is that not exactly the same? Oh, because it used to be that I had separate async disposable and async lifetime, which I don't need anymore because I got rid of dispose async as a separate thing. Now I understand why I had 5 failed tests instead of 4, like I expected. All right, so these should be in collection fixture. That's class fixture. Let's go to collection fixture. Okay. So this is constructor. Constructor. So you look like this. Throwing CTOR, throwing CTOR. Throwing CTOR fixture, good. Oh, you have the word assembly instead of the word collection. And then the last one is look, copied, die in a fire. So your initialize async. Wait a minute, test class with throwing collection fixture dispose, not initialize async, dispose. Here dispose. You're a collection fixture. And you're using throwing dispose fixture. Good. Okay, one more set. Async collection fixture, what do you look like? Just those. Collection fixture async setup should only run once. But I don't like the test collection runner. I'm confused because this thing doesn't have this don't double run me, bro. Right? So should I have an async assembly fixture here for this? Let's. Because what you're implying is that my initial as async test should go down there. Right. We're just going to call you a plain test class. We're not going to call you a test class. How about that? So there's constructor, there's dispose, here's dispose async. Right. Dispose async. Let's roll all of these up. So you should go there, which means the plain test class should go here. All right. Now, assembly fixture, async setup should only run once. Run async test pass fixture 1, fixture 2. There's fixture 1, except that's not a fixture, that's test class. You can tell I didn't write these tests. You're going to be assembly async once. You're going to be actually don't need any of that. Actually, we don't need any of that. Assembly async once, assembly async once. Counted async fixture. So the way that that gets tested is we need fixture 1 to be mux assembly fixture attribute type of counted async fixture alpha. Right. Okay, so let's say alpha fixture. Data fixture is mux assembly fixture attribute type of data. And then here we want additional is alpha and beta. Test class 1, test class 2. Okay. So that's now you can just be assembly fixture, async assembly fixture. So that's that and that. And that and that. All right, you can get a little smaller now. Now for async class. Fixture data should have been set up as on top. Okay, what about async collection? It's not. Okay. Throw if not completed, throw if not, it's different. Test is the same, but different. Whatever. Fixture spy. Throw if not completed. Plus async setup should result in failed test. Throwing class with throwing fixture async dispose. We don't need the disposable version. Throwing dispose async. We don't need. Throwing setup we don't need. Class with throwing initialize async. Class with throwing fixture dispose async. Throwing fixture initialize async. Okay. And then in class fixture, we're going to need to fix those as well. All right, let's go get xunit test class runner. All right. Put you over here because we want to copy stuff from over here. All right, so this is the select for initialize async. Oh, that's horrible. So how the collection runner work? One work too? Create. No. Select. So that's a list of tasks. That's a list of tasks. Okay. Class fixture through an initialize async. Very good. And then this is constructor. So this is constructor. Class fixture mappings. Class fixture through in its constructor. And then we have, where are you? So your dispose and you're the select on dispose async. And you should have the word class in you. Okay. Weird. Throwing setup. All right. Yes. All right. So throwing initialize async fixture. What else? Throwing dispose async fixture. Forgot I deleted those and didn't clean it up. All right, 4 failures. Not 5. All right, so this is throwing async setup. So you should actually be throwing initialize fixture, initialize async should result in a failed test. That's down here. All right, so that's initialize async. This is a class fixture. Then this one is dispose async. All right, that is a class fixture. That's half of my problem right there, right? It is indeed. The other half is throwing fixture constructor, throwing fixture dispose. Throwing fixture constructor. And then dispose. All right, everybody. Very nice. Okay. Let's run all the tests and take a look at what we did. Okay, so we needed to update acceptance test to take additional assembly attributes. We did not actually need to do this. And in fact, we should undo this. So this was acceptance test v3. Run sync comes back down here. Diagnostic message sync is null message sync instance. All right. Better. So we have the mock attribute. Reflection assembly info now can take extra additional custom attributes. So you should have a better name. Reflection assembly info. Additional assembly attributes. Alright. Additional custom attributes to return for this assembly. These attributes are added to the existing assembly level attributes that already exist. Okay. Next. Yep. So let's ignore space changes. It's better. Additional custom attributes, reflector. Additional custom attributes to return for the assembly. These attributes are added to existing. Okay, so I failed on spelling twice. Which makes sense because I copy-pasted it. Alright. Additional assembly attributes. This is typically only used for unit acceptance. Why don't we go add that? Over here. Okay. Okay. You get bigger. 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 Okay. Assembly fixtures. These are all the tests we just wrote. Don't really need to review those. Runner tests. So you needed, yep, assembly fixture mappings. You needed assembly fixture mappings. Assembly runner takes in assembly fixture mappings. Well, generates them, actually. And there's all of our new code. This class runner now needs to take in assembly fixture mappings. There's our new stuff. There's our new stuff. This collection. So, some interesting things I don't think we've tested yet. Let's see, what's still left in my notes? Alright. Test that we can compose assembly into collection, assembly into class, and collection into class. I don't remember seeing those tests. And in point of fact, probably exists on XUnit test class runner. So these are the arguments into the test class itself. But like constructing test class may not be decorated with ICollection fixture. Decorate the test collection instead. Sure. So go get all my iClass fixtures and then do a create class fixture async for each one of them. And then go get iClass fixtures off of the collection. So that's kind of interesting. You can go decorate the collection with an iClass fixture of T. Because assembly fixture yeah. I guess assembly fixture is just a little bit special here. Could you have an assembly level collection fixture attribute? That is really the question here, right? Should we support assembly level collection class fixture designations? An excellent question. Okay. So create class fixture async. Create class fixture. Get the constructors. Go find collection things to put in there. This is weird that this is down there like that, right? So this is the test class runner. So what I need here is else if Oh. All right, we're going to come back to that in a minute. And the next unit test collection runner. So do we have a create test collection? Create collection fixture? We do. So then that's that. So then to do allow assembly fixture arguments. Same here. We also have, what is it called? Test context accessor. I kind of feel like we should do that. And then XUnit test assembly runner. You've got create assembly fixture, right? There you go. Okay. So there's some more tests. Some more things. So all of these tests ran. And then we need our acceptance tests. So these are fixture acceptance tests. All right, so in class fixture, we have this class with extra argument to constructor results in failed test. Missing is acceptable. Task class with throwing is a failed test. Failed test. Fixture data is passed to the constructor. All right, that's this. So what I need here is I need public async void. Class fixture can accept let's not do it here. Let's do class fixture composition. Class fixture can compose from collection fixture value. So what does this look like? Test class with class fixture composition. Oh. So my composed fixture will look something like let's just call this fixture composition because I think I'm going to do them all at the same time. Okay. So your composed class fixture. Composed collection fixture, Hello. My guess is I'm going to actually have other stuff here in a moment. In fact, I know I am going to have at least this. Oh. Okay. For the moment. Okay. Wait, run, async. Tests passed. We obviously need this to get into there with mocks. Nope. Yes. So you also need class, let's see, you need test collection, I guess just collection, right? And what's your problem here? Instead of asserts here, let's stash these things. Perfect. Okay. Not gonna work. We'll see. Apparently not. Let's take a look at all the messages. Composed class fixture had one or more unresolved constructor arguments. Composed collection fixture. Composed assembly fixture. So we could not match composed class fixture, composed collection fixture, or diagnostic message link. So the class fixture couldn't even compose the collection fixture, but it's possible that that's because the collection fixture is currently composing the assembly fixture. All right, so we know we need that. So let's go through everything we need in, what we think we need in. So if not, assembly fixture mappings dot try get value p dot parameter type. So is that what we're doing in collection runner? Oh, this is assembly runner. This is wrong anyway. So we need to allow assembly fixtures there. We need to allow assembly fixtures there, which we are now. That, in theory, means I should be able to match at least one of my parameters now. No, I didn't want to run. I wanted to debug anyway. Well, let's see what it says. Yeah. So in the class runner, so if that fails and this fails, then we do that. How about now? Still failing. Let's see if we can figure out why. All right. Fixture acceptance tests. Fixture composition. Let's make this run faster, eh? You're killing me, Smalls. Is it up here? Yeah, there we go. Class fixture acceptance tests fixture composition. Okay, let's see what test failed is telling us. Composed had one or more unresolved. Composed collection fixture. Composed collection fixture couldn't be resolved. Why? So you're in this collection, right? Which has a collection fixture of composed collection fixture. This is a class fixture of composed class fixture. Does this have to be public? Nope. Well, we got a different message this time, didn't we? Did not have matching fixture data, so you can't pull a diagnostic message sync in here. That's fine. Let's say pull one from class, make sure it matches the one from collection and assembly. That should be fine, right? Test passes. Very nice. Okay, what else? Oh, these also can go in the test, can't they? Create and assign remaining as fields. Now, I should also be able to bring in a test context accessor, test context accessor. All right, that doesn't break me, right? Correct, that does not break me. All right, test context is going to be the test context accessor dot current. Let's do not null. There's diagnostic messages, and then there's this. So let's do not null test context accessor for starters. Class fixture test context accessor. Selection fixture, assembly fixture. Same test context in the class. Selection fixture, assembly fixture. All right. That should fail. Yep, that should fail. Not in a super happy way either, buddy. But we know what the problem is. Else if p parameter type is type of I test context accessor, arg is test context accessor dot instance. All right, I need to put you there. I put you there. I need to put you there. Run that test. Okay. Oops, I need to do it there, I need to do it there. Go away. Run everybody. All right. Feeling pretty good about this. Yeah, let's do one more add. And we'll just do a full test pass. Excuse me. All right. Test assembly runner now. There's a whole bunch of stuff for test assembly fixtures. Test class runner takes assembly fixtures, matches the accessor, and uses the assembly fixture mapping now. Right. And then Collection runner takes the assembly fixtures. Adds test accessors and assembly fixtures for arguments. Good. Okay. Sort of expect all of this to do its thing, which it looks like it's doing. We're on our way to MS build. And this is a fix for 1947. Fix is 1947. Add IAssemblyFixture. Add AssemblyFixture attribute. That's really what it should be called. Okay. Let's go to main. Throw dev onto main. Push. Back to dev. And just push up the sticky note. There you go. And we'll throw up the actions. We should have a build. That should be doing its thing. And with that, I think we're going to call that a day. That was quite a long session, almost 5 hours. So this feature was a little bit bigger than I expected. And I am now way overdue for calling my friend. And also for getting some dinner. I'm hungry. So anyway, thanks for hanging out with me. And I hope to see you next time.